Hello guys, in this video we'll learn about procedural macros using Rust. If you are working with Rust programming language for some time, you should already be aware of the power that macros brings to the table when programming Rust and how heavily we use macros for Rust programming, be it a very basic hello world application where you just print something, or a complex application or project where you are using serialization, deserialization, and threads and whatnot. Macros are literally everywhere in Rust. Now if you're new to Rust, then macros in Rust allows us metaprogramming by generating the code at compile times. Basically it takes care of all the complex jargons and logic, and then you can reuse. Just like we use functions, we can reuse macros as well. And there are two types of macros in Rust: declarative macros and procedural macros. Now in another video on my YouTube channel, I already covered about declarative macros. If you haven't checked it out, it should be popping somewhere on right top. Make sure to click it, watch it before moving on to this one. As part of this video, we'll talk about procedural macros. While declarative macros are pretty simple and straightforward, procedural macros are custom macros that operate on Rust code's syntax tree, enabling advanced code transformations like deriving traits, modifying functions, and generating new code structures. Basically, procedural macros provides you more control on what you can achieve with macros. And we can do that with function-like macros, attribute macros, and derive macros. And trust me, when we start writing our own macros like function-like, attribute, derive, a thought will strike your mind that, hey, I have used it. Maybe while serialization, deserialization, I have used something similar. And that is exactly the concept behind these. So we'll be adding our own macros and then we'll be using as well. So without further ado, let's dive into it and let's begin. We'll talk separately about each of these: function-like, attribute, and derive macros. And as we start, there's a link to my Discord in description. Make sure to join it. We are building a community of like-minded people where we share tons of things. So make sure to join it. So first of all, move to an empty directory. And here, as you can see, I don't have any projects yet. So we'll add a couple of cargo projects, one where we'll consume it and one where we'll add basically library that exposes our macros. So cargo new, and let's name it create macros as lib. And then another one that we need is use macros. That's it. So there we go. We have both now, create macros and use macros. Now just open both of the projects in any of your text editor or IDE that you prefer. I'm using Helix editor. And here in the first tab, we have our library, which is create macros. In the second tab, just for differentiation, I have used different colors of the text editor, like different themes. And here we'll be consuming in our main, and then this will be using as a terminal. Now, first of all, let's add a few dependencies that we need for create macros. So let's move to create macros, and here we'll add cargo add syn. This crate basically processes Rust code into a syntax tree, which allows our procedural macros to analyze and manipulate code structures. So once we add syn, another macro that we need is quote, cargo add quote. And the code crate helps generate Rust code dynamically by converting syntax tree elements into tokens. So let's move to our cargo toml, and here, as you guys can see, we have both of our crates added. And then we have to set lib proc macro as true. And as you can see, the proc macro field indicates that the library is a procedural macro. So basically it signifies that this library contains procedural macros. Now after that, one thing that we forget is we need full of this. So let's add it, version as 2.0.96, and the features we need as full. So once we have it, now let's move to our librs. And let's go ahead and add our first procedural macro. So we'll start with function like macros. So let's add our first function like macro. Function like macros basically work like similar to println. Basically you pass any statement and it goes in and it compile times convert the println to the actual code. So something similar that we'll be coding today as our first function like macro, where we'll basically pass a string and the number of times we want to repeat it, and then it will basically get us the repetitions. So let's start with our proc macro. So pub fn and repeat is the name, and then we get input as token stream, and the output that we return is also token stream. And on top we'll just add proc macro, and then we have to parse the input. So parsed input is equals to, and we get a macro for that as well, which we can use. So it's called as parse macro input. We don't need it for now. Parse macro input, and then we'll just say input with punctuated, and here we'll just say expr lit and a literal in place of expression, so we'll be using this. And token, another macro we want to use, so token, and separated by comma, and right here we'll just say parse terminated. So this, and then once we have our parse input, we want to check that the length should be equals to 2, not more than that and not less than that. So parse input dot len not equals to 2, then return. Now this will help us understand how can we raise compile time errors as well. So what we can do is error from sin and new spawned, and here we can send our parsed input as token, and here we can just say expected 2 arguments, a string and a number. And once we have that, we'll just say dot to compile time error dot into, and once we raise this, if that's not the case, then we'll just pick up both literals, so string literal and parsed input of 0 as our string, and string times, so times literal and parsed input as 1. So this helps us get both the number and the string, like how many times we want to repeat the string. And now we want to also check that the first argument should always be a string and the second argument should always be a number. And how do we do that? We'll just say let string value match and string literal dot lit, and here we'll just say lit and str s dot value. Else, if that's not the case, then we'll again return error and new spawned, and here we'll pass our string literal, and then we'll say first argument must be a string literal dot to compile time error and into. Actually we just do comma here and a semicolon here, and similarly times value and match and times lit dot lit let as integer I and match I dot base 10 parse u size okay v then v else error then return error new spawned, and here we'll just say times literal, and second argument must be a valid integer. To compile time error into, so we get our both now times as well as times value and the string value, and we also have to add case for this match where it doesn't match. So again it's same, just return the error. So return error new spawned, and here we'll just pass our integer times literal, and the message is second argument must be string integer. Into compile time error and into. So we have times value, and the final thing that we will be doing is using the quotes. So output, and we'll be using quote. So here we'll just do is vector, and let's say string value dot to string and times value, and then we get our output, and then we just do output into, and that is literally all that we need to write our first function macro. So just ensure you have all the imports properly, everything. Once you just do the write, the code doesn't show you any error, just make sure. So once we are at that stage where our first macro is ready, now let's go to the consuming side where we'll consume this, so which is this use macro project. Now let's move to the second project, and here in the cargo toml we'll add our create macros project as a dependency. So we'll just use its name here, create macros, and here we'll read it from a path, and the path is, there you go, the folder. So we read it from here, and now let's move to our main RS. And things are pretty straightforward here. We just do is extern create macros and use create macros. As you can see, there's a repeat function already for us, so let's use it and add our main. So let result is equals to repeat. There we go, we have our repeat. So repeat, and we pass the string as, I don't know, let's just do hello and 3 times. Then we just go ahead and print our result, and let's save this, and let's move to our project, which is use macros, and we just do cargo run quite. There you go. As you can see, hello is printed 3 times, and that's exactly what we do in our repeat macro. Now let's say we just pass hello, expected 2 arguments. As you can see, the error raises at the compile time, which is this one right from here, expected 2 arguments. And what if the first argument is a number? There you go. First argument must be a string literal, which is again from our right here, where we are expecting the first argument to be a string literal instead of number. There you go. And similarly, if we just pass 1, or just say hello hello. There you go. Second argument must be an integer literal. So basically all of our compile times error, as you can see, getting raised, and the macro works sound. So this is our first macro, and let's say if we want to repeat 100 times, and we write and we run, there you go, hello printed 100 times. So that's from our first macro. Now let's go to the second type, which is derive macros. If you have been working with structs and Rust, you should have used a lot of derive macros. For printing, you should have used debug. For serialization, deserialization, you should have used macros from Sarday. And similarly, clone, copy, and a lot of other macros as well. So here we'll build our own first derive macro, and we'll name this as debug special. So as you know, the debug macro goes in and prints all of your fields, its values, and in our debug special macro will only print it if it is not none. So let's get into it and let's build our first derive macro. So let's name this as debug special, pub fn debug special derive, input as token stream and output as token stream, and on top we'll add proc macro derive, and here the name of trait. So we'll name this as debug special. Now just like debug, once we attach this debug special on top of any of our struct, it will use the logic which is here. So first of all, we'll, same as in the functional macro, we'll parse the input. So input parse macro input, and input as derive input this time, and let name. So this will give us the name of our struct. And now let's access the fields. So we'll just say let fields is fields, and if let data struct, and here we'll just say and input dot data. This will give us the data match, and s dot fields. So right here we'll say fields and named fields named and named, and then named dot iter dot map, let field name as fname and f dot ident. This gives us the name, and let's get the value. So quote, and if let sum, as I mentioned, will only print if it's a non-null. So and self fname and fields dot push format, so name and value, and then we'll just say stringify fname and value, and then let's handle for s dot fields. So panic debug special only supports named struct fields. So we'll only support for named structs, And then once we get our if sorted, we'll just add else, and that will just panic. So simply just panic, and we'll say debug special only supports structs. Debug special only support structs. So if you want to wrap it on something else, then we can add the implementation, but right now we only support it for structs. And that sums up our if and else. And now let's work with fmt to write it, expand it, and quote impl fmt or standard fmt debug for name for the struct, and fn fmt and self and mutable std fmt formatter, and there we just return std fmt result. So let mutable fields is equals to vac new, and fields, and then we just use the write f, and stringify fields dot join, so to print out all the fields, and return with expanded dot into. So that's for our debug macro. So once we have our drive macro ready, let's use it. And pretty straightforward here. Again, we'll just do is extern create and create macros, use create macros debug special, and debug special, and then we add our struct here. Let's say we call this person, it has a name, a string, and let's use optional string here, and age as optional I32, and country as optional of string. And on top we add derive and our macro, which is debug special. Then we go all the way down and add our main, and right here we just say let p is equals to person, name is some string from semicolon, and let's for now age is none and country is none as well. And then we just do print p, and let's do cargo run. There you go, we just prints the name and not the none for others. So let's say instead we just try to add country as well, some string from USA, and then we run. There you go, it prints name and country. So this is our debug special, which is our first derive macro, and I hope you guys understand how can we build our own drive macro, where to use quote, and how can we parse the input as well. Now once we have our drive macro, let's move to the final part, which is attribute macro. Now let's add the final type, which is attribute macro. So At the end of the video, I'll give you guys a summary of when to use which. So for now, let's add our attribute macro, which basically helps us log the execution time, let's say. So attribute and token stream item token stream and token stream, and on top this time we'll just say proc macro attribute, and let input is equals to again proc macro input, sorry, parse macro input, parse macro input, and we pass item as item fan, and once we get the input, we'll just do is let fname and input dot sig dot ident to get the name, and block, which basically gives us our function block, so function name and function block. So from signature, as you can see, we can get ident, we can get inputs, but for now we'll just use ident. And once we have block as well, we'll again do the expanded work, which is quote and let start is equals to, for suppose we use std time instant now, and fn block let duration, so we execute our block, and start dot elapsed, and print ln execution time of the function name and total time. So the name will just say stringify fn name and duration, and right here we'll just wrap it in fn name and right afterwards we'll just say expanded dot into to return. So pretty straightforward. In this attribute macro, we'll just wrap it on our function. Let's remove this. So now let's use it. Now here let's use it. So extern debug special, state of debug special. Now we should get log execution time, and after that let's remove all of this. And let's say we have a dummy function fn dummy, and that dummy does the sum. So what it does is it runs from 1 to 10,000 and sums it and prints it for us. Sum is equals to sum, and then on top we'll just use log execution time, and in our main we just call this dummy, and let's give the type here as well, u32. Now we just do cargo run quite. There you go, it prints the sum and the execution time as well. So we reduce it, let's say 1 to 10, and there you go. So that's where we can use attribute macro as well. Now let's check a summary of when to use which, since we understand how to build each of these. So let's take a look at the summary of when to use which macro. Declarative macro, when to use. Define reusable patterns that operate based on the input syntax for code generation and metaprogramming, as I mentioned in the video that's pinned in the description. And then procedural macros, when you need to transform or generate code programmatically, used for advanced code manipulation. And the three types are function macros, used for operations like println or the repeat that we just used, where you want macro calls to act like functions. And then attribute macro, used when modifying function struct behavior, like adding custom behavior, just like we added log time. And then derive macro, automatically implement traits or functionalities like for structs, so just like we added debug special. So that's it for this video, guys. I hope you like and understand and learn something new. If you do, like the video, share with your friends. I'll catch you guys in another video with another interesting topic. Until then, bye bye.